So I want to start with today, just how do we sort of more at the, mile high level, the way above the fray, think about disasters, and how do we think about these events and things we're going to talk about over the course of this semester. So the first one, I suspect everybody here has experienced a disaster. I don't wish that on everyone, but what are some of the disasters you guys have gone through or been affected by? Anybody?
In 2007, I'm from San Diego. We had that huge fire.
Okay, gets fire. Okay, cool. Other people?
The Thomas Fire in 2017.
Totally. Thomas, huge. Other folks?
There was like a really bad snowstorm 2019 in the Pacific Northwest, and they called it Snowmageddon.
Yeah, Snowmageddon. Yeah, that was crazy. Totally.
So I have a question. What would you classify as a disaster?
Oh, we're going to talk about that. But my first point was just to see what you guys would say when I asked you this question. Excellent point. So whatever you define it as.
Yeah.
Okay. And what kind of event was it?
So I'm from France. So in 2012, we had a really big snowfall, and it was like a lot of fun.
Okay. So snow. So excessive precipitation. Totally good. Other people. Other things or events. Yeah.
The Thomas Fire in 2017.
Yep. Thomas Fire. Absolutely.
They weren't anything big, but earthquakes. Frequently around here.
Yeah. Totally. Yeah. I have grown up in California, and I unfortunately am too used to earthquakes. And the story I usually tell when I introduce, when we talk about earthquakes, is I was a graduate student at UCLA, and I was TAing a class on marine biology, and there was a midterm coming up. So we had a study session in a room very much like this, but it was in a tall tower. So it was on like the 6th or 7th floor or whatever, this tower, and it was at night. And so I always remember, so we were doing the anatomy of a crab. So I'd drawn this crab on the board, and I was having, as a practice session, I was having the students label all the different anatomies. So I'd draw a body part, and I'd like face the board, and I'd, what's this? And somebody say gill, and I'd write gill or whatever. And it was maybe about as many people as you guys are in this room. And I was sitting there, and I'm writing, and then a little bit of shaking. Shake. And like we shook for, a few seconds or whatever, and then it stopped. Like, okay. And then I was like, okay, what's this? And somebody's like, antenna. I'm like, okay. And so, I was facing the board the whole time. So I turned back around. I'm like, okay, so next, and just about everybody's making notes in their notebooks, except for these two young ladies in the back. And they were like up straight, and their eyes were super big. And, we're talking about, hey, what about this fish? And they're just like, what the hell? And then after a little bit, like I see one kind of turn to like say something to the other, and they kind of say something back and forth. And then finally, this one lady raised her hand. I go, yeah. She goes, was that an earthquake? I was like, oh yeah, it was a small one. Like, oh my God, should we get out of the building? Should we run? I'm like, no, it's fine. And they were like, but I think, and I said, oh, if you guys are worried, absolutely, you guys should. We're gonna go. And they left the review session. So your question about what is a disaster and what is it? What do we mean by these things is totally cool. So those folks, I wasn't trying to be a jerk to those students, but it was a common occurrence for us. But they, not having been from California, they never experienced that. And so even a little bit of an event, if you're not used to it, can seem very scary and can be very impactful on you. So cool. Okay. Anybody else? Any other? We heard some Thomas fires. We heard some snowstorms. We heard some. Yeah.
It wasn't like a big one that everybody knows about, but I know in the high desert, like they were installing like solar panels. But before that, they had to like loosen up the sand or they did something, and then one day it was like 50 miles per hour wind, so the town was like affected with a dust storm.
Oh, totally. Yeah, absolutely. So wind events and bad air quality can be a huge thing. In fact, that was really, so the famous a smog event in London well over a century ago had at its roots or from that has grown up much of our air quality policy from that one really bad disaster. And as we'll see this semester, disasters have, because they're a crisis, because they cause significant impact, they're an important impactor or driver of policy. So we tend to develop laws and approaches and stuff based on what happened, usually what didn't go right in a disaster. Oh my God, now we need to create a fire department. Oh my God, now we need to create a different water infrastructure for this place, or whatever the case may be. I venture to say all of you, or almost all of us, have experienced a disaster, and increasingly we're impacted by these things, even if we're not directly our body or our home physically impacted. We are impacted at a society, at a cultural level. So these folks in this Caribbean island are experiencing a disaster, right? So in this case, a bunch of rain, a precipitation event that has taken out their bridge. So when we have something like this, it's very, very clear, right? We used to have a bridge, now we don't have a bridge. So that's very visceral, and that impacts most of our life, right? So these guys, if they want to go to school, if they want to go to the store, it's even if their home wasn't flooded, they now have significant impacts upon them. So what do we mean by the term disaster? So disasters are the result of a hazard, which we'll talk about in a second, overwhelming a highly vulnerable community, most often understood as causing death or other injury to people. In recent years, the last decade or so, we're having increasing numbers of these types of events, right? And so we have on the order of about 300 so-called natural, quote-unquote, disasters around the globe in any given year, right? So that could be some of the things you guys talked about. It could be precipitation events, could be wind events, could be wildfires, could be earthquakes, all these various things. The impact, the direct and immediate impact of these disasters around the world are humans directly affected, at least in the context of millions of people directly, and the direct costs, at least in the context of many billions of dollars, right? And these things are only increasing as we're going through time. So before 2 years ago, in 2022, just as we were about to start this class, we had a big giant volcano explode in the South Pacific. And that's what we're looking at here. We're looking at what looks like an atomic blast is actually the volcano going off. And that had all kinds of consequences. Obviously, immediately to the people that live closest to the center of this volcano. But this stuff threw up ash up into the atmosphere, impacted air travel, all kinds of stuff. So that's like 2022, for example. This is last year. We had this new series of eruptions going off in Iceland. In this case, this is another type of volcanic activity, but in this case, not so much an ash plume. This is a lava event for the most part. But this is having impacts also in and around things like air travel in Northern Europe and things of that nature. And then obviously we've just had our own series of wildfires here in the LA basin. This is one of those. This is the Palisades Fire, and this is a time lapse of the spread of this particular fire. A characteristic wind-driven event, characteristic, unfortunately, increasingly characteristic of these events getting out of control. We don't have good rain or traditional amounts of rain in an area. And so this sucker just kept spreading. As you guys know, it's still not fully contained. So it's still growing. As we'll learn when we talk about fires, by containment, we mean containment is used for a wildfire. This is different from an urban fire. But a wildfire is burning through landscapes, trees, shrublands, grasslands, things like that. And containment means that we have a fixed perimeter around the entirety of the thing. It doesn't mean that the fire has stopped burning, but it means the fire can grow no larger than the spatial extent to which it exists at that point. That's containment. So when you hear people saying 10% contained, that means 10% of the perimeter is the fire can't go beyond there, either because we've knocked the fire down there, or because we've set a backfire, or we've created a fire break, or some type of intervention. So that was last couple weeks. Then this is today. So here we are today. So this is a couple hours ago.
Copter 76 on 01,
This is up by the Grapevine.
2025, 1306 hours on the Hughes fire. Current acreage is 5,053 acres as reported by Intel 24. Helicopters working this right flank from the heel at the top here all the way down into the heat mid-slope, switching to SWIR. You can see that heat carries all the way down the right flank, down to Castaic Lake. Fire's currently bumping Castaic Lake, staying so far on the east side of the lake. End of recording.
Okay, so we're so much on the attention now when a fire breaks out here in Southern California, given the recent events. Now it's late breaking. It's live featured on the New York Times website, right back in New York City. So a tool that maybe some of you have been using that has become quite. It's been. The use of it has grown increasingly over the last several months and last couple years, but it really exploded as the LA wildfires went crazy. So this is Watch Duty. Have you guys used Watch Duty? Let me ask a different. Has anybody not used Watch Duty? Let me ask that way. So a few people hadn't. So maybe like 10% of you guys have not. So for everybody, was created by this Silicon Valley dude that lives up in Sonoma County, and his house, big, nice, giant house out in the natural landscape area, house was threatened by wildfire a couple times. And he tried to find out information. He was frustrated of how hard it was to, as a lay person, to go in and find what's going on, what's this and that. And so we have a huge bureaucracy. Another key theme that we will see this semester is the bureaucracy that's built up around responding to disasters. And bureaucracy isn't inherently a bad term. Oftentimes when we hear it, we think it's a bad term. But it just means this big structure around organizational structure. And we oftentimes associate bureaucracy as a negative because we usually are using it as an example of something that's become so big it's become clunky. It's so big it's become ineffectual, that type of thing. And so he took some of his tech, Silicon Valley tech money and said, I'm going to make a nonprofit, and that nonprofit is going to take all these different feeds, which exist, which you all pay for, we all pay for as citizens. So satellite data and firefighter reports and weather data, and just pull it together for, and this is focused on the Western U.S. and it's focused on wildfires. And so where can we go to have a one-stop shop to, if I'm worried about a wildfire breaking out near where I live or work, or when it's broken out and I'm trying to figure out what's going on. Is it a little teeny tiny baby fire? Is it a big giant fire? Should I be worried? Should I not? Any of those kind of questions, you can jump on Watch Duty, and it's free. You can have it on your phone as a free app. You can have it on your iPad as a free app. You can have it on, you can access it through your computer, through a browser, as we're doing here. And there's all kinds of data layers there. This is all free. If you want to pay an additional monthly or annual subscription, you get even more data. But all the basic stuff, all the most important stuff, evacuations, weather, stuff, that's all free. And it's a nonprofit. It's committed to provide this stuff for folks free. I think they were getting something like 100,000 calls, meaning requests to see the website a second as the Palisades Fire was blowing up, and it worked really well. So it's pretty cool. So if we just take a quick look at this, we're not going to talk about this fire, for the rest of the day. But just if we look at it, what you see is this is the power of some of our modern technology, right? So all of our infrastructure in California is oftentimes criticized, or oh, we spend too much money. We have a tremendous amount of data. We have a tremendous amount of information available to us and to our, in this case, firefighting professionals to understand the current situation and predict what might be happening in the near future, warn people, all that kind of stuff. And so what we're seeing here is an interactive geospatial data layer on the left here. So here we see the fires in LA that again are still burning. They're not out. They're getting close to being fully contained, but they are not fully contained. So they are still a quote unquote wildfire. But I can click on any of those and find information about them. I can find evacuation stuff, whatever. If I click on the Hughes fire, the current one we're talking about, we'll get initial stuff. So evacuation orders for various areas. And this will bring both the raw stuff to you and some synthesized information. So this kind of stuff, which if you're in the back and it's too small to see, that's fine, don't worry about it. But this is typically what we historically have gotten from these agencies. So they are like old teletype type of output, right? Text-based stuff. Hey, it's from AZ21319 to 4, and you're like, what the hell? I don't know. I'm not from that area, or I'm from this part of the county, not that part of the county. What's that? I don't know. So it will suck in all of these data sources, but it'll also translate them for you, right? It'll make it more intelligible. So rather than just giving the verbal or the text-based, the written word-based description of stuff, it'll also try to help you visualize stuff. So it'll, on this map, so if I click this stuff, it'll say this, if this is an evacuation or the fire perimeter or all these different things. And again, I can zoom in to look at all these different elements. I can look at weather and all this kind of stuff. I can come down here and I can look at different measures of the fire intensity, different evacuation maps. We can see real-time cameras. So this is part of a network that's based out of UC San Diego with UC San Diego and San Diego State, where we've deployed all these real-time cameras around the state. And we use, it's not, people call it AI, it's not AI, it's machine learning. It's related, but it's not the typical large language model stuff that most people associate with the term LA. But what this is doing, this is sucking in, this is the most recent picture of a camera pointed at the area where this fire is. And right now, we can just use it to monitor. But also what this network does autonomously, 24 hours a day, 365 days a year, is look out for things that are correlated with in the past the outbreak of a fire. So it can use infrared sensors, it can use smoke plumes and everything. You'd say, oh my God, human, look over here, human, look over here, human. And so then you can go check and see, oh my God, does this look like a fire starting? So really, really helpful. And so all this stuff is brought together through this platform called Watch Duty. So pretty cool, so pretty useful. And they're constantly refining this and doing all kinds of great stuff and making it better in all types of ways. Here is the real-time air quality. So this is purple air. This is not created for disasters. This is created for people to understand what their environmental quality is. And this is a citizen science project that early on many people poo-pooed and thought was not very helpful. The Environmental Protection Agency said, you can't have these cheap sensors, and you can't have little school kids and rando homeowners doing it. It's just not going to be good quality data. So these sensors cost about $200 a pop. So they're not free, but they're certainly affordable, right? So the typical types of air quality sensors that we use in our formal air quality monitoring, say with the county, those would cost, depending on what we're talking about, those would cost, tens of thousands of dollars for each unit, right? So tens of thousands of dollars versus 200 is a huge difference. And so what you're looking at here is a heat map of all the publicly available purple air monitors around. Green is good, red is bad. So the lighter the color, the better the air quality. In this case, what we're measuring is the particulate matter in the air. So the little pieces of stuff that could come from soot, that could come from the combustion of a diesel engine, what have you. And what we see is we just look at the LA, and well, there are a couple patterns here. One is it's not everywhere, right? Where there's more humans, there are more sensors. So it's not a perfectly evenly distributed sensor network, but still, right? If you just kind of squint your eyes, you can see it's kind of mostly green here, right? In the sort of greater LA basin is mostly green. But then we get up to where campus is right now, right? And where Lake Hughes is up here on the 5, and we see, oh my God, there's something really horrible. So either they've installed a bunch of coal plants in the last hour, or what we're picking up is the dust and the debris and the organic matter and the soot produced from this wildland fire, the burning of the grass and the trees and all that kind of stuff. And that's in fact what we're seeing. So again, green is good, yellow is orange starts to get into, hey, if you have respiratory, if you have asthma or some kind of respiratory thing, be a little bit careful. And then by the time we start getting to these reds and purples, like nobody should be outside. They can avoid it. Everybody should have a mask on, that kind of stuff. And sure enough, we're seeing that signal from this particular fire. So a great example of how the fire is not physically threatening us right now, right? But we have all these ancillary effects. So one of our students texted me before class. She couldn't get here because the road was physically closed because of this fire, right? So there's that kind of social dislocation. But then there's also the health impact. So even though you're not threatened with flames at this moment or whatever, right? You are getting a little bit harmed, right? A little bit of the smoke isn't going to kill you. But right, if we have this extensively, it might cause some problems. If we lived in this for days and weeks on end, it might cause us some problems. And again, those of us that are more vulnerable to air exposure to this kind of stuff, they might even have a problem with this level of pollution. So a great example of how these things can impact us in many different ways.
Not for watch duty, but for...
Yes, okay, so they were originally installed, so this is the purple air map. They're originally installed as just a citizen science project to help people understand what their air quality was like. So there wasn't a specific goal, it was just let's help people understand.
What year was that?
The first purple air sensor, I don't know, I think I put the ones at my house in maybe like 8 years ago or so. I think they probably started maybe at least 5 or 6 years before that. So they've been around for, I don't know about it might be more than 2 decades, but it's at least 15-ish years they've been around.
And watch duty, how old is watch duty? It's been around for several years.
No, well, the gentleman founded his NGO several years ago, but the first really robust app was only about 2 years ago.
It used to just be a website.
Yeah,
Okay.
yeah. Cool. Yeah, and again, with all the attention of the users, that's bringing more money in. So I guarantee that whatever functionality it has, it's going to get even better. It's going to be, next year, it's going to be even a more useful tool to folks. And in fact, one of the news stories I saw this showed LA County's Emergency Response Center, where whenever you have an earthquake, whenever you have a biological hazard, whenever that kind of stuff, where they activate their emergency center with all the police and all the command and control and everything. And on this big gigante screen in the middle of front, they have watch duty, right? So that's a measure of how useful this is, that even the folks that are the professionals that do have the feeds find it useful to have this sort of pulling everything together in one spot type of feed. So that's pretty cool. Okay, so let's first talk about natural hazards. Okay, so we did a little bit about disasters. A natural hazard, a hazard versus a disaster. A hazard is the threat that something might happen. Specifically, the definition of a natural hazard is a threat to humans, to people, right? When that threat is manifest, hey, we're worried about a flood, so this valley is hazardous. This valley has a natural hazard, right? If, then next week the rain comes and the water flows down the hill and does flood that valley, then when that flooding happens, that kicks us into the disaster. So the hazard is the potential, the disaster is when it's realized, when it actually occurs. Okay. So we often use the term natural disaster, right? So we talk about a tornado, natural disaster, wildfire, natural disaster, right? It's just historically how we've referred to these things. But these hazards and the ultimate disasters that come are generally thought to have derived from non-human processes. The volcano erupted. The wind caused the air to move around, then induce a tornado. The rain came out of the sky and caused the flooding, right? So it's nature. It's natural forces in the world doing their natural forces things. The term natural hazards, and indeed most of these types of classes in most universities, were derived from mostly geophysicists, geologists, those kind of folks that were looking to articulate some of the risks from things like earthquakes and volcanoes and stuff like that. And so that's the initial thinking of this term natural disaster. Unfortunately, given the way our world has evolved, even though we frequently use the term natural hazard or natural disaster, it's less helpful now because it sort of implies that humans aren't a part of the equation. So for practical purposes, when a hazard negatively interacts with us meaning me, us meaning my family or loved ones, us meaning my community, or something we really, really care about. I love football. If that fire destroyed the football stadium, that kind of thing. So when that risk is manifest by hurting us, that's usually when we turn to things like a disaster to apply the term. Once we start trying to define disasters, we get into a huge bureaucracy, right? There's a huge system that's built up both globally as well as inside the U.S., inside our state, and everything around this. So, for example, here is you probably can't read the specifics here, and that's fine. But this is from a recent paper that looked at academic studies of disasters. And you can't quite read it up at the top here, but this one right here says where is it? Where's my mark? Okay, this guy here says pre-disaster. This one says during disaster. This is post-disaster. And so if we just look at these, what we see is the vast majority of tick marks, it doesn't matter, are to the left side of this. So most of our academic research, most of our professional investigation as to what's going on here is usually directed at the conditions that lead, which is understandable, that lead up to the event, that lay the groundwork. What was the condition before? What were the things that kind of made it be as big as it was, right? That type of stuff. We see many fewer tick marks in this literature review as we go towards the during the disaster and sort of immediately post-disaster. There is a huge bureaucracy. So this is an illustration of the FEMA, Federal Emergency Management Agency, which we'll talk about. The FEMA bureaucracy, but you don't need to look at the specifics, you just need to look at all these lines. It's like this thing affects that, and that guy needs to talk to that, and she needs to talk to her, and right, all that kind of stuff. So we tend to not rigorously explore the bureaucracy of how we respond to these things, but these bureaucracies are often very complex. And so that's also part of the story of disasters, is how we define these things and how we work through them. So there's all kinds of terminology, and I'll just give you an example here. Don't worry about copying these down, but just have a look at these. So this is the United Nations World Health Organization, which we've apparently just decided we're leaving for the first time ever. We're one of the creators of the World Health Organization. As of this week, we've decided that it has no value to us as Americans, so we've decided to leave it, which is foolhardy, I would say, but in any event, here's some definitions from these guys. So they have a definition of hazard, for risk, for disasters, incident. And so what we see here is first first this idea of risk, and then this idea of it's the same idea we just saw, the sort of the potential for harm, and then when the harm happens. Then we see for the first time here the idea of maybe some differentiation in the intensity of the harm. And we have all these definitions from different organizations around the world and different groups. But I think the simplest thing is this. So we'll use this for our class. Or this is a framework. I mean, I'm not saying you have to use this, but this is, I think, a useful framework. Everybody has these multi-part definitions and stuff. Let's just keep it fairly simple and straightforward. The first would be when we do have an event that happens, it is useful. It's important for us bureaucratically. It's important for us to prioritize, all this kind of stuff, to draw some distinctions. So not every single event is the end of the world, right? And if we react to everything at the end of the world, we're going to burn through all our resources and burn out everybody's energy and all that kind of stuff. So let's look at a very simple range of things. So one is emergency, and then something that causes problems and is like more bad than that would be a disaster. And then something that causes even more problems and is more bad than that would be a catastrophe. So we have emergency, disaster, catastrophe. So I'll show you the official definitions in a second, but we'll just suffice this to say, here's a simple way to think about it. My house catches on fire, that's an emergency, right? So oh my God, my lawn is on fire. I call the cops, it's an emergency. My neighborhood catches on fire, that's a disaster, right? My county catches on fire or my state catches on fire, that's a catastrophe, right? So key to this, it might be the same event, it might be the same kind of thing, it might be fire, it might be wind, it might be whatever. But we use these terms, while in common speaking, we might use them interchangeably, but in the context of disaster professionals, we want to show gradation, and those gradations really reflect on who's impacted and how widespread that impact is. So a definition we'll use from the Federal Emergency Management Agency, the official U.S. federal agency. An emergency is an unexpected event which places life and or property in danger and requires some kind of immediate response. That's an emergency. Okay, so your house is flooding, the fire is coming towards your porch or something of that nature. So that's emergency. Disaster, that was great. I made them all available to you. Okay, so disaster is when a community, so that's more than one person or more than one unit of a thing, when the community undergoes severe danger and incurs some kind of loss. That loss could be human life, that loss could be infrastructure, what have you. And then the third example in the intensity scale is catastrophe. And so that's not just the community, that's the society level stuff incurs something. So the pandemic would be an example of a catastrophe, right? Now it's a little bit early it's a little too early to say what's going on with our current LA wildfires. Clearly, it is absolutely a disaster, no question. Whether it's getting to the catastrophe area is a strong possibility, but we're not clear. So there's a very strong possibility that this event here in Los Angeles is going to impact home availability across the state, insurance rates across the state, and maybe across other states, right? And so that's pushing us into more of the societal level impact, right? And so again, a little bit too early to tell. We're at least a disaster. This might end up being eventually considered a catastrophe. Does that make sense? Okay, so emergency, disaster, catastrophe. And then another key thing, just by way of introducing us to this topic, is again this idea of natural hazards, natural versus people, nature versus humanity, that type of thing. And so let's be a little explicit about what we mean by these things. So nature or natural aspects of things are an inherent property of the environment or the inherent capacity of the environment to do something. gravity pulling the rocks down off the hillside. Rain coming from precipitation coming from a cloud, condensing and then falling down to the ground, that kind of thing. Anthropogenic is something that is entirely, or the vast majority, driven by human decisions and human management actions. So in this bureaucratic world of understanding disasters that we're in, and this trying to define everything, we have many different definitions of, or many different categorizations, of disasters and the types of disasters. So, for example, common natural disasters, quote unquote, would be biological. So a virus breaks out and starts attacking all the corn crops or something like that, right? Or every so often, the locusts emerge and go and eat the crops and stuff like that, right? So that'd be like examples of biological stuff. Then we have abiotic or non-living natural events. And so that would be things like geophysical. Remember, we talked about the fact that these types of courses and this thinking was originally born out of the geophysicists' world. And so they're going to first and foremost talk about volcanoes, they're going to talk about earthquakes, they're going to talk about the earth moving and the geomorphology leading to landslides and things of that nature. Okay, the next, I'm just sort of giving you guys a mile-high view here. So there's many sub-things within each of these. But then the next one would be hydrological, meteorological. That would be storms. That'd be your typhoons, your big massive snowmageddon that you guys talked about, that kind of stuff. And then things that are not coming from the Earth. So that would be meteorites and asteroids, right? So stuff could crash down and kill the dinosaurs, that kind of thing, right? So we consider all those things, generally speaking, historically, as natural hazards and leading to natural disasters. Okay, on the other side of the coin, we have things like technological hazards. So this could be something like we are, I don't know, a train wreck or something, right? So the train is going and the train goes off the rails and it kills a bunch of folks and the train runs into the library and destroys the library, that kind of thing, right? They could be societal, right? So this could be something like everybody gathers for a festival or for a religious gathering or something like that. And the fact that all these people are here in an area, they trample a bridge and that causes the bridge to fail or something because too many people are walking over the bridge or something of that nature, right? So that was driven by society. And then we have this sort of one little category here, socio-natural, right? And I should say all of this stuff comes from this United Nations this particular categorization comes from this United Nations a framework about disasters and where things come from. Because it's a United Nations organization, by definition, they've excluded a war. So one of the biggest causes of disaster and destruction and catastrophe are humans actively trying to slaughter other humans, right? Setting off nuclear bombs, burning the forest down, all that kind of stuff. But by definition, those active conflicts are excluded from the UN definition of anthropogenic, even though they clearly are. Ooh, great one. Ooh, okay, good. So crimes would clearly be societal. Arson, I'm not sure. I don't know where we'd put arson. I think they would say that humans, okay, and then this gets to the problem of this thinking, right? Which is that by the general broad definition, if the arson takes a match, touches the match to the grass catches fire, the grass starts to burn, that would be a hydrometeorological event. right? That would be a natural, that would be a natural disaster, quote unquote. Because the people aren't actively,
The crime is creating an
right. But again, this gets to the problem. The problem is now, I should say another one here that I've sort of blotted out because it's just not something we're going to talk about in this class, is just general environmental degradation. So stuff that's going on day in, day out, adding copper to the river and various things like that. This is clearly an issue. This can lead, in effect, to having disaster type manifestations. But that's really, we're talking about more discrete events here in this class. So that's an important thing. That's a real thing that happens, but that's the subject. Many of our classes cover that. We're gonna for the most part, maybe acknowledge that, but we're not gonna focus on that in this class. It's the take-home message, right? Which is that historically we thought of these things as the non-people dealio that maybe impact people, but they're mostly non-people-y things going on. And then there's the people-y things over here. The reality is there's almost no such thing as a quote-unquote natural disaster anymore in this, according to this classical framework. It is true that we can get earthquakes just because of tectonic plates doing the stuff they've always done. But we've now found very clearly that we can induce hurricanes, that we can induce earthquakes, right? By pumping out oil and gas, by pumping out water, by injecting fracking fluids and things of that nature and wastewater. Absolutely, we can influence that. So yes, most earthquakes we humans aren't causing, but even earthquakes now we're beginning to exert some influence on how they occur. Volcanoes are probably one of the ones that are the most sort of non-human-y influenced factors so far. So I don't know of any studies where we humans have directly influenced the frequency or the occurrence of volcanic eruptions. But even with volcanic eruptions, we are so abundant and we are so numerous across the face of the planet now that even if we didn't start the disaster, even if there wasn't an arson person that started the fire, the manifestation of the disaster is absolutely strongly influenced by the human side of the equation, right? That's because maybe 150 years ago, if we had that lightning strike that hit that top of that peak in eastern Ventura County, and it set the whatever on fire, the pines on fire, and it kind of burned down, it would maybe, affect some people, clearly, probably, but, affect a few people, right? Whereas now we have the 5 freeway going through the Grapevine. Now we have all of our reservoirs that are on fire right now in this Hughes fire. Now we have all the stuff. So now that maybe that same magnitude of an impact, the same lightning strike or nearly identical lightning strike, maybe nearly identical a flammability of the grasses and stuff, boom, that happens. And now the impact is much larger because we humans' footprint, our footprint has gotten so big that these things are impacting us. So even if we're not directly influencing the onset of the disaster, as it progresses, the consequences are made worse by our choices to put infrastructure there, our choices to put houses there, our choices to transport our goods and services across this corridor, all that kind of stuff. So there almost is no such thing as a quote-unquote natural disaster anymore. It's more a degree of human influence versus not. And increasingly what we're finding here is that our signal is increasingly conspicuous, not just in the impact of stuff, but with things like these fires, right? So for example, the most recent analysis from last week from some colleagues at UCLA suggested that, I don't remember if it was the Palisades or the Eaton fire, but one of them, the fuels, meaning the stuff that's burning, so the chaparral, the shrubs and the grasses, are at the time these fires started, were 24% drier than they would have been in a quote-unquote normal year. We're 24% drier had we not thrown all this carbon up into the atmosphere over the last 150 years. Right? Now, does that say that we caused the fire? No, it's called attribution science. I mean, maybe there's an arson, maybe it wasn't, but maybe it's a down power line. We're not sure. It's still being investigated. Maybe it was a down power line. But the point is, regardless, even if that power line had fell down, or even if that individual had tried to set that match to that piece of grass, it was 24% easier to get going. And once it started going, it was 24% easier to get to grow faster, right? So that's what we're talking about. So it's not that any one particular disaster was necessarily started by a human, but our actions, both in priming the system of the earth to be more, to tend towards more disastrous occurrences, and our vulnerability by creating our living space and infrastructure and all this kind of stuff, which is more vulnerable to these more intensive, larger scale things. Both those together make it the case that pretty much there's no pure natural, if there ever was, there's very few natural disasters anymore. So that's what we're going to be covering this semester and going into depth in those things. Make sense? Questions about that general stuff?